And welcome. My name is Ryan Holger. I'm going to be your tour guide for the next hour or so, and today we're going to be talking about variable speed inverters from ICP, which would be Day and Night and Heil and those types of brands. I'll probably refer to them mostly as the 5-stage units because personally I think 5-stage sounds better than variable speed, but I know the marketing folks disagree with me, but I do what I want. So if you have questions as we're going along, please type them in the question chat box down in the bottom right-hand corner, and I'll take a pause every once in a while and try to answer them. If there's a ton of them, I probably won't get to them until later, but I'll try to answer a few of them as we're going live here, especially if multiple people are asking the same thing. And like I said, this is being recorded, so your coworkers, you can share it with them later on if they want to see it or need it or etc. All right, so what's an inverter system? These are high efficiency systems for heating and cooling. Obviously heating would be a heat pump version and cooling would be the AC type version. And these units are going to operate at multiple speeds depending on what the house or the building needs at the moment. They work a lot differently than a traditional air conditioner or heat pump, which responds to a thermostat closing a relay saying I'm hot, or maybe 2 relays for a 2-stage unit. These work a lot different. These thermostats on the wall send their temperature and humidity data meaning both the live data as well as the set points, over to the units themselves, and then the units modulate their capacity based on how far from set point we are and how fast we've been getting to the set point. So for you guys that are familiar with commercial controls, it's basically a PID loop, or maybe some of you might want to think of it as like cruise control for your car. It automatically adjusts to get you the exact speed that you need, or the exact engine RPM to get the speed that you need. This is going to work in a very similar way. It's common for these units to run very long stretches and modulate up and down. The higher the speed of the compressor, the more BTU capacity we'll be able to get out of the unit. The condenser fan will also modulate in conjunction with the condenser speed, or excuse me, with the compressor speed. So we're modulating both of these things simultaneously, along with the speed of the indoor fan. So 3 modulating things at a minimum to get me the capacity that I need. And then our speeds of these 3 things, indoor blower, outdoor condenser fan, and the compressor, will all change as we get closer or farther from the set point itself. The reason that a lot of dealers like you guys are using these units, and these are not new per se, these have been out for about a year, almost a year or so. So I guess that's still kind of new, but not like brand new. But the reason dealers are typically using these, the main thing is small size. This is pretty easy and pretty portable as far as air conditioners go. And it is a lower price point than a lot of other units. So it's cost effective and smaller. And there's a couple other features too as we'll get into stuff. Inverters are becoming a lot more common. They've been becoming popular on mini split type systems for a few years now, but now you're starting to see them on traditional ducted systems, which is what we're talking about here today. You're going to be able to provide customers a very high level of comfort. I've had a 5-stage inverter at my house for about a year and a half, so I've had one full summer with it, if you will, and about to go into my 2nd summer, and it's been phenomenal. My wife doesn't really get excited about HVAC things, but she's commented a few times about the 5-stage air conditioner and about the modulating gas furnace that we put in a year and a half ago. She can't tell that they're running, but it's always the perfect temperature and humidity, so it's pretty cool. Homeowners want these not just for comfort, but they also want them for efficiency. These units get up to 19 SEER efficiency. As most of you guys know, the efficiency is dependent on what kind of furnace or fan coil you connect it to and airflows and things like that. But you can get up to 19 SEER. 19 SEER is not the highest thing in the market, but it's a very good high efficiency type point. And you can also get up to high EERs if you need to. Most of these units come in 2 versions. You can order it either way. You can order with the regular EER or with the high EER. And we'll talk about that more as we kind of go along. For my friends that have heat pumps, which I know is not a huge thing in our market here in the Chicagoland area, but for some of the guys that are logging in from Wisconsin, Minnesota, Missouri, I saw a few people. Heat pumps are probably more common for you guys than they are here in Chicago where I live. But they do have a pretty good HSPF. Not the highest in the world, but certainly higher than the minimum. This allows people to save operating costs compared to regular traditional systems, obviously. But the real reason that someone's going to want this is not going to be because of the SEER rating. It could be, but that's not going to be the main reason. It's going to be comfort, just like everything else. People don't typically buy a variable speed lower because it's going to save them $150 a year on their fan bill, right? They buy it because they want the comfort, and the energy savings just goes along to boot, right? Same thing with these inverter compressors. They're going to buy it for comfort, and then the energy savings just kind of helps them sell themselves on why they quote unquote need it, you know? So you're going to get really long run times with these things. The one I have at my house, it'll turn on, and instead of, you know, turning on and off every 10, 12, 15 minutes like a normal air conditioner would, or worse, if you have an oversized one, it might turn on every 3, 4 minutes. But instead of turning on a normal schedule, mine will turn on and it'll run 20, 30, 40 minutes at a time before it actually shuts off. And then if it's a really hot day, it could run the whole hour, which is fantastic because the longer it's running, the more it's dehumidifying. So it's been really nice in that regard. You got a wide operating range for both indoor temperatures and outdoor temperatures, and you can handle lots of varying conditions when you have multiple capacities like this built into one unit. Not any different than a modulating gas furnace or a modulating condensing boiler. These types of things have numerous variable capacities, and this condensing unit is no different than that. Humidity control is by far one of the greatest benefits. In order to dehumidify, you obviously have to get the air of your home that's going across the evaporator coil. You have to get that air down to the dew point, right? So when you first turn your condensing unit on, it starts sending you some cool refrigerant to your evaporator coil, and that starts cooling down the air going across it. But when it first kicks on, you're not at the dew point yet. So you're cooling for 3, 4, 5 minutes before you actually do any dehumidification. Right? So if I can keep this unit on longer by running it at lower stages, I can get through that initial period and then continue running it to get that dehumidification that I need without overcooling. So the humidity control is phenomenal. You're going to be hard pressed to find anything other than some specialty, you know, process application equipment, you know, like a Liebert unit or something. You're going to have a hard time finding anything else that's going to do dehumidification like this kind of unit can. It's also fantastic for zoning systems. As you might imagine, with zone air systems, you're shutting dampers down to choke off air from going to certain rooms, right? And you're only sending air to the rooms that really want more cooling. Well, when you do that, if you got your unit, you only had a 1 or 2 stage unit, that's a lot of BTUs you're trying to shove down 1 or 2 ducts. If I'm able to throttle the compressor capacity back, at the same time I'm throttling the airflow back, because I don't have all the zones open, I'm able to handle that pretty well and keep long run cycles, prevent short cycling on the zoning system, prevent the bypass air from getting too cold, that sort of thing. Sound levels are fantastic as well. A lot of these units have been installed because of sound. A lot of engineers, consulting engineering firms, have spec'd them because of the sound levels. Just last month I had 2 different, one engineering firm bring 2 different clients in because they had, you know, the penthouse suites on top of a high-rise condo, and there'd be a bunch of condensing units on their roof from all their neighbors, and they didn't want any, you know, sound effect. You know, the guy that lives in the penthouse probably paid the most for his condo, so they wanted really low sound level equipment, and this is something that they're using in order to do that. Having dBAs in the mid-50s is pretty low. You've never had an air conditioner for, you know, a regular traditional ducted system that's ever been below 60 before, so this is pretty freakishly low. In fact, it's so quiet that the ones that I have in my training labs, when I have technicians in class, or class for, unrelated to this, just for whatever, it could be a thermostat class or a boiler class or whatever, sometimes I'll go and put one of these units on in the lab on low stage and just let it run. And then later on in the day when I'm talking to the people in the class, I'll point that unit out and say something about it and say how quiet it is. And people will say, well, turn it on, let's hear it. And I'll be like, dude, it's been running for an hour and a half since we've been in this room. And people are freaked out by it. And they can put their hand above it and they can feel the airflow, but you can't hear much about it until you get pretty close to it. So it's been really quiet unit, freakishly quiet. For the air conditioners, they come in 4 different sizes, 2, 3, 4, and 5 ton sizes. You will not find any half sizes for these inverters, which is fairly common for some of this type of equipment, because now that you have the modulation capacity, that extra size in the middle is not as big of a deal, because I can always just prevent it from going to the 5th stage. So if I needed a 4.5 ton unit, I would buy the 60 size, which would be 5 tons, and I might just tell it only use stages 1, 2, 3, 4. Or maybe I would let it use all 5 stages, but it probably never would on its own. We mentioned the SEER and EER ratings. The size and the weight have been significantly reduced compared to equivalent 19 SEER 2-stage units. So instead of getting 2 stages, you can get 5, and it's quieter, smaller, lighter. So all that's working kind of in your favor. There's a couple things that the 2-stage units do better than the 5-stage unit, and I'll point those out in a little bit. But for right now in your head, just think of it as awesome. If you can get that thing lugged into a yard with 1 guy instead of 2 guys, that's probably a benefit just in and of itself. There's also a second model number for most of these units. We call them the odd sizes because instead of a 24,000 beats unit, it's a 25, instead of 36, 37, and so on. It doesn't necessarily mean it gets more BTUs. It's just that we've given it a different model number to designate that it is in fact different. And what this allows you to do is you get pretty much the same SEER ratings, but you get a higher EER rating. And we'll talk about SEER versus EER in a little bit. But in some parts of the country, like the Southwest, they have requirements for not just SEER, but also meeting a certain EER. So these units are used in those climate zones in order to just be legally installed. And they also help you hit certain targets for programs like Energy Star as well. In general, the chassis of the unit gets larger when I go to the odd sizes to get the higher EER. So the size goes up, the weight goes up, the cost goes up in order to get that high EER unit. So you're not going to put it in unless you actually need it for your application. Heat pumps, very similar scenario. You know what I should point out too on the air conditioners, there's no 61 size. That's because in order to get the size 25 unit, the 2-ton high EER model, we have to put it into the 3-ton cabinet, and then the 3-ton goes in the 4-ton cabinet, the 4-ton goes in the 5-ton cabinet essentially, and there is no 6-ton, so there's nothing to put a 5-ton high EER in, if that makes sense. So the 2, 3, and 4-ton can come in high EER models. The 5-ton cannot. If you need a high EER 5-ton, you'd still have to use a traditional 2-stage unit. Heat pumps, it's all a very similar story. Lighter weight by a lot, 134 pounds lighter than an equivalent to 19 SEER 2-stage unit. So smaller in size, smaller in footprint, smaller in weight. And on that one, the 2 and 3-ton have odd sizes available, but the 4 and 5-ton do not. Couldn't get enough surface area capacity by shoving that 4-ton in the 5-ton cabinet to get it done, so they didn't build that. I'm sure they're working on it. I don't see any questions yet, but if you guys do have questions, please type them in the chat box, and I'll try to get some of those answered for you. When you do this 5-stage unit, this variable capacity unit, you're going to want to use it with the observer wall control that's available from ICP. A traditional thermostat does not know what to do with a unit like this, right? Even a 2-stage thermostat, which is probably the highest amount of stages of cooling you can buy, and even if you could freakishly find a 3-stage stat on the market, you're definitely not going to find a 5-stage residential stat. So those 2-stage stats don't know what to do with 5 stages of capacity. So you need to have this observer control on there. And what that guy does is not only does he act as your thermostat for the homeowner, set points and major interface type discussion, but it also controls the capacity of the unit itself. So it controls the indoor blower, the outdoor compressor, and the outdoor condenser fan to get the BTUs that are required. And it does that by looking at both the temperature and the set point and how fast we've been getting towards the goal of hitting our set point. And it sends that information to the indoor and outdoor units so they can adjust their speeds accordingly. So not just what temperature is it, but what temperature is it right now, and what is it again 30 seconds from now, and again in 30 seconds. Am I doing a good job? Am I doing a bad job? Give me a little more, give me a little less capacity, that sort of thing. Not all observer controls can handle the 5-stage unit. Only the current ones can. So that model number there on the screen with version 5 software in it is what you need in order to operate this. Older versions of the observer stat from 3 or 4 years ago or whatever, they wouldn't know what a 5-stage unit was, so they can't control it. So you have to have this current model number of stat with the current version of software in there that came out about a year ago or so in order to actually operate this stat. Bruce is typing in, does the unit explain what electrical readings are for all 5 stages? You can see the voltage of the unit from the thermostat screens, but that's all you can see. That's the voltage incoming from the power utility. You will not be able to see live data on the thermostat about the electrical readings. Probably because most homeowners aren't interested in that. A service contractor maybe, but the homeowner probably wouldn't be. But you do get other information on there. If there's specific faults related to electrical problems, Bruce, those faults will get reported to the stat. So if you had like an arc detected issue or low voltage issue from the power utility, it would tell you that on the screen of the thermostat. But it's not going to start giving you voltage and amp readings or kW demand or anything like that on the screen. These compressors have a very, very wide operating envelope. A normal two-stage compressor, a normal scroll two-stage compressor that we've used in condensing units for this past several years, obviously when it's on stage 2, it's 100% capacity. When it's on stage 1, it drops down to about 70%, usually between 67 and 71% depending on the model of the unit, which is not very low. It's still 2/3 or more, right, of the capacity. Well, this thing, when it goes down to stage 1, it'll drop all the way down to 25%. So that allows me to match the load pretty precisely when I can operate it at all those points between 25 and 100%. And that allows me to get better temperature control, better comfort, better dehumidification, and it allows me to be much quieter when I'm on stage 1 of a 5-stage unit versus stage 1 of a 2-stage unit. We'll show you those stages side by side in a little bit here. We call this compressor technology SmartSense. That's kind of the little tag name for it, if you will. And it combines the intelligence of the circuit boards in the indoor and outdoor units along with the circuit board in the thermostat to do all this really cool math. It's nothing like crazy extravagant. It's not like you're doing differential equations here or something weird like that. It's pretty straightforward math, but instead of you doing it, it's all being done inside the computer for you and giving you the precise control that you actually need. From a dealer's perspective, the ability to sell these, you can sell them based on high efficiency, which is great. I think you're really going to sell it based on comfort because that's the real story, and efficiency is just kind of a bonus. You get very consistent discharge air temperature out of all the registers. Dehumidification is phenomenal. My indoor set point in my own house is up to 78 degrees now for temperature because I'm able to dehumidify it pretty significantly. And most of you guys probably know if I can keep the humidity lower, I'm more comfortable at higher temperatures. Kind of like we've always done in the winter with humidifiers, right? If I add a humidity to your home, instead of keeping your house set at 72 degrees, I can keep it set at 68 or something like that, and you'll be equally comfortable. Same exact thing happens in the summer. If I can dehumidify your house down to 52% humidity instead of 65, then all of a sudden, instead of having a 72 degree set point, maybe you're comfortable with the 76 or 78 degree set point. So that humidity control has been key. I mentioned the zoning being beneficial as well. You can use a 2-stage thermostat with this unit if you want to. I would not recommend you do that, but it is possible. The reason you probably would do that is because the observer control, as you may or may not know, whenever you hook that up to a system, it can only be hooked up to an indoor furnace or fan coil that speaks the observer communication language. So if you're doing a new install of this condensing unit and a new furnace at the same time, you get the furnace, you get the condensing unit, you get the wall control, everything works great, you get full 5 stages, everybody's happy. But if you have an existing furnace, let's say you already have it, they bought it 3-4 years ago, they don't want to get a new furnace obviously, but they need a new condensing unit, you could put this condensing unit in with a 2-stage thermostat and run it in 2 stages instead of 5, and then down the road when they're ready to replace their furnace, then you could do that. So there's a way to run it with a 2-stage thermostat if you want to, but you will be losing 3 of the 5 stages you will lose. I mentioned the sound levels. I said mid-50s, 56 dBA. That is at the low stage capacity, just so you're aware. As it speeds up, it will get higher. So you can see with the typical air conditioning unit, there's a 2-ton size in that example. 56 dBA at the low end, 71 at the high end, right? Because we're speeding up the compressor and speeding up the fan. I have these in my lab, and I have one at my house, and I cannot hear the compressor at all, ever. I can hear the fan. I can hear that when it speeds up when I'm standing outside by the unit, but I cannot hear the compressor. The fan is literally louder than the compressor, which is kind of crazy. 71 is not that loud. It's pretty decent. It's like a normal quiet condensing unit would be, but 56 is freakishly low. So if you can keep things running on stage 1, 2, and 3, you end up with pretty low sound levels if you can avoid stages 4 and 5 most of the time. And if you think about it, the only time you need high stage really is when it's like 93 degrees outside or something crazy like that, right? And at that point, your neighbors probably aren't hanging out in the yard. They're probably inside, so they don't care if your condensing unit's next to their patio being louder than it would have been otherwise. Having an inverter on here has its own benefits as well. An inverter is basically like a VFD, right? Like we put on a commercial fan or a commercial pump. So it's a soft starter, meaning that when you first turn it on, you don't get a big inrush of current. and you don't have the dimming of the lights or anything like that would happen. It's a slow start. It ramps up gradually, so you don't get that initial spike. You don't hear that initial sound. You don't have the light dimming, that sort of stuff. So it's pretty quiet on startup as well. I mentioned the size is pretty small, a lot smaller physically and lighter than a typical two-stage unit. And generally speaking, these units can be installed by one person, especially the 2 and 3 ton sizes. To let you see that visually, this is a 2-scale drawing. On the left is this inverter unit we're talking about. In the middle column is the 17 SEER unit, and on the right column is the quote-unquote old 2-stage 19 SEER. So you can just see visually, right, from a footprint standpoint along the top, how much smaller it is, and then even height-wise, it's smaller than the current 19 SEER. John is asking what voltage and phases are these available in. John, these are strictly residential units, so they're going to be 220-volt single-phase units only. Once power comes into the unit, it does get converted into a different voltage and actually 3-phase, but that's inside the unit after the inverter. So from an application standpoint, just your typical 230-volt single-phase. From a weight standpoint, you can see there at the 152 pounds, this is a 3-ton unit. At the 152 pounds is the inverter there, right? If I'm comparing him to the regular 2-stage 19 SEER, that's 283 pounds on the far left. So it's almost half of the weight of a normal 19 SEER unit. So physically smaller dimensions and lighter as well. The other cool thing about this control, even though it's controlling 5 stages, I don't need a bunch of wires. I can get it all done with 2-wire communication. So from the wall control to the furnace, you have 4 wires. And then from the furnace out to the condensing unit, you carry 2 of those wires out there. So the good news is most retrofit applications, you only have 2 wires in the wall anyway. So if I already have 2 wires in the wall, I don't really need to run any new wire. So life is good, and I can get this all done pretty easily. Because I usually have 4 wires from stat to furnace, and I usually already have 2 from furnace to condensing unit. So that makes life easy. Those 2 wires carry all the information, so they send over all the requests for the 5 stages. They send over requests for defrost mode. They carry all the alarms back. If there's an alarm on the outdoor unit at its circuit board, it goes over that same 2 wires and tells the thermostat. So instead of relays, it's basically communication. The thermostat basically sends a little email over to the unit and says, I would like this amount of cooling, please. And the unit says, okay, I'm going to give it to you. And then if there's a problem, he sends a message back saying what the problem is. It is pretty easy to set up, especially for you guys that do heat pumps. The biggest pain in the butt for heat pumps, as far as I'm concerned, is getting my thermostat to play nice with my system, right? Because I got a reversing valve on there, and I have to tell it whether it's normally open or normally closed, whether it's an O or it's a B, right? And the equipment manufacturer may have chosen to do it one way, and the stat manufacturer may have defaulted the other. So I got to figure out which one they want and get it set for that by moving a jumper or configuring a screen. It's kind of a pain in the butt. And I've been to plenty of people's houses when they said it's not working, and it's because they have the heat pump reversing valve wired backwards. But anyway, all that wiring goes away because if you can't get 2 wires right, then we got bigger problems in life. When you charge these units, you got to make sure you get it to run at stage 5, which is harder than it actually sounds. You got to really kind of wait a little bit for it to kind of ramp its way up to the 5 stages till you're at max capacity, and then you can do your charging. And we'll talk about that more in a little bit. You get fault screens on the stat, so if there's a fault code, it gets stored in the stat, and then the service tech can look at those faults later on. You get basic information. I'll show you some screenshots of some of the data that you'll be able to see. You can limit the staging. If you don't need all 5 stages, you can limit to only do certain stages. We'll talk about that. And then you can see what equipment, serial numbers, and model numbers you have connected to that thermostat. Tracking run hours has been very beneficial. We've been doing that on some of these observer stats before even having this inverter unit. And it's great to be able to see that data or show someone their 2-stage unit and be like, dude, you've only kicked on 2nd stage like 4 times. Probably this thing's oversized kind of thing. All right, so some of that info has been great to have over time. Where does this fit in with our current product lineup? We still will continue to have the 1-stage communicating smart unit. I personally think that's kind of dumb. If I have a limited budget, right, I'm not going to buy the 2 or 5 stage because my budget says that's not a good choice for me. I'm not buying the 1-stage communicating. I'd rather take that money and get a 2-stage non-communicating with the same amount of money, right? So personally, I'd rather pretend that 1-stage unit's not there. for this high-end stuff, right? There's also low-end versions of the ICP units too, like mid-tier and entry-level units. This is just the high-end stuff that has the communicating observer control capabilities. On the two-stage side, the 19 series unit is going to be getting eliminated. It's already been kind of going down that path already in favor of the 5-stage 19 series, right? Because why would you want to get a two-stage 19 series that's bigger, heavier, and louder, less efficient as far as part load conditions are concerned. So it doesn't make any sense to have that unit. So that's kind of going by the wayside. So if you look at a different way, this is kind of the way things have been moving. We saw some of that happening towards the end of the summer of 2016 and into the fall, and we expect this to continue on now that we're going to have a full summer of these inverter units available. The 17 tier 2-stage people may continue to use that, or they may upgrade to this 19 tier 5-stage, and then the 19 tier units we're going to phase out and expect you to use the 19 tier 5-stage in those applications. So what's really different in these units? Is it more stuff I have to install, more stuff I have to service? Is it scary? Are things painted a funny color that throws my eyesight off? Like, what's going on in here? By the way, there's no funny paint colors. I don't know why I said that. So one thing that's different is the condenser fan motor. It is a compact ECM. So instead of having a motor with a drive attached to it like we've always had to do when we wanted to have variable speed condenser motors, this is everything in one, if you will. And the actual drive capabilities of the ECM motor are in the inverter. The same inverter that controls the compressor speed is going to control the fan motor speed. So because of that, it's become smaller, which means that I can reduce the height of the unit slightly, and it means that I have a less expensive component hanging there for the motor, if you will. But I do have the inverter, which is a more expensive component, because I've never had that before, right? So there's an extra thing involved here. We'll look at the inverter details blown up in a little bit in the end of the hour here. But the inverter, just like an inverter on a commercial fan or pump, he takes power in from the utility, converts that power to something that he can modulate, and then sends that over to the compressor, and in this case also to the condenser fan, to control the speeds of those two different things. The compressor is a DC motor, not AC, right? Which is great because the inverter already knows how to control DC stuff pretty well. The compressor is also rotary, which is different than something we normally use in the United States. I mean, I'm not saying we don't have any rotary compressors, but the United States and Canada have been kind of squirrel countries for several years now, 15 years or so, ever since we got rid of receps. But the rest of the world really went the rotary route. So once you get outside North America, rotary is dominant. And this compressor is coming over from Toshiba. They have an agreement set up with ICP and ICP's parent company to make these compressors for them. And it's not a new compressor at all. Been using it for several years in the ductless world. So now we're just using it in a ducted application. But the really great benefit of it is I can throttle it from 100% down to 25%. So it's a 4-to-1 turn down, a 75% turn down. We look at these inverter units side by side with their two-stage brethren. The technology we feel is a little bit better. We can do more stuff with it, like I mentioned with the turn down. So the variable speed rotary versus the two-stage scroll has had its benefits. The penalty that I'm paying for that, one penalty, is that I can't get as high VER. It's not that I can't get it with the rotary compressor. It's just that to get the high ER with the rotary compressor, I would have to put it in the big cabinet that the scroll compressor is in, right? But we could have done that. We could probably give you like a freakishly high, like 25 SEER unit or whatever by putting a rotary into the old cabinet. But we figured the energy cost savings is pretty minimal, and people would rather have the reduction in size and weight. So we put the rotary in a smaller cabinet, but because of the smaller cabinet, that's less surface area, so the sacrifice is EER. The benefit is you get the 5-stage versus 2-stage, and you get the freakishly low turn-down capacity down to 25% instead of the usual 67 to 71% that you get on one stage of a 2-stage unit. Smaller weight, smaller sound. Two things to watch out for, especially for you guys that do some light commercial type stuff. On a normal 2-stage unit from ICP, we can typically do about 200, 250 feet of refrigerant piping. On these inverter ones, we're maxed out at 100. Normally, it's not a big deal. For a residence, that's definitely not a big deal. But if you're going to use this in some kind of light commercial application, then you might want to pay attention to that. And then likewise, the low ambient, same kind of discussion. On the two-stage units, we could have gotten low ambient control down to 0 degrees, which means when it's 2 degrees outside, I could run my compressor for cooling, right, on those kinds of applications. With the inverter unit, that is not the case. We can only get down to 55 degrees outdoor operating temperature, or if I put the observer control in there, I get more stages, obviously, right? I can go lower staging, so I can go down to 40 degrees outdoor ambience. For a house, that's totally fine, and for a condo, that's probably fine. But if you were thinking about putting this like in a server room or something, that's not the right spot for this particular unit, right? Go stick with the two-stage units, the traditional scroll units, if you want to have, true low ambient cooling below 40 degrees. Heat pumps, exact same kind of discussion that we just had, right? Same kind of line set length and low ambient cooling type discussion. I just put this chart in here just so that the heat pump guys in attendance would see this chart as well. But it's the same exact story as the AC because it's a very similar unit, obviously. When I look at all these models side by side, let me see if I can get my little pointer arrow out so it can make it a little easier to follow what I'm saying. Hopefully you guys can see that little red dot. It's part of your eye test for today. The red is the even size of the inverters. The blue is the odd size, which is the high EER. The yellow is our traditional 19-SEER two-stage that we've had, and the purple is the 17-SEER two-stage. So you can see for EER, that older style 19-SEER scroll is the winner in every case. But EER, as you're going to see in a little bit here, is not all that important. EER is just peak, whatever happens at peak. So when it's crazy hot outside, how efficient am I? But who's better at part load is going to be the real question we'll answer later. But you can see at part load, the inverter unit is not doing as well, not because it's an inverter, not because it's a rotary, but because it's very small and does not have a lot of coil surface area available to it to get that high EER. So if you need high EER, all you care about is EER and SEER is not your thing, which is weird, but if that's what you cared about, because some program requires you to have that to get certain free money, then this would not be the unit choice for you. You probably have seen this chart, and if you live in another area, I can send you a chart for your area. So if you're in Kansas City or wherever, I saw some guys logged in, and I can send you a chart like this if you're interested. EER, this is for Chicago. I live in Aurora, which is an hour from Chicago, so this is the closest weather data I had available to me. Let me get rid of my little arrow thing so I can go back to normal here. Oops, too much stuff. So EER for all manufacturers is calculated at 95 degree outdoor ambient. So that's where they run these tests for these units, right? Why did they pick 95 degrees? I don't know. Somebody picked that number however many decades ago. They said you need to get it from 95 degree outside down to 80 degrees indoor, and that was the target, right? Well, in real life, nobody nowadays thinks 80 degrees is comfortable. I mean, in the 50s, that was great, but nobody cares about 80 degrees anymore. Now you want like 75. Right? And 95 outdoor temperature only matters if you're like south of the Mason-Dixon line. For everybody else, the amount of time we spend at 95 is pretty much nothing. And you can see on this chart for annual run hours, you can't even see a sliver where the 95 degree day would be, right? At the 90 degree point, we probably only have 25 hours in the 90 degree bucket, which is like whatever that is. I think 88 to 92 degrees or whatever, that little purple line there, right? The real situation is, what am I going to do when it's 70, 75, 80, 85 degrees outside? How efficient am I at those points in time, right? So high EER only happens at 95 degrees, so who cares? How efficient am I the rest of the time? And SEER right now is the best indicator we have of that. And even the SEER test isn't that great. It's really kind of optimized for 1- and 2-stage equipment and doesn't really represent 5-stage equipment with load turn down very well. But SEER is still a better metric than EER, and residentially, those are the only two metrics we have, so that's kind of what we're using right now. So the SEER rating is more important than the EER rating for actual conditions in most climate zones. You have to use the correct observer control wall thermostat in order to get the high SEER. So if you look at these, on the left-hand side, those two tables are the air conditioners, and the right-hand side is heat pumps. So I'm just going to look at the air conditioners for right now. 2, 3, 4, 5 ton size on each table, the same EER, 11, 11, 11, 10, 11, 11, 11, 10, but the SEER ratings change. So on the 3-ton example, which is a very common size, if I put the observer wall control on, it's an 18 SEER unit. If I put a 2-stage stat on it, it becomes a 16 SEER unit. That's because I'm not going to get the opportunity to use stages 1, 2, oh, actually I'll use 2, If I put a 2-stage stat on this 5-stage unit, it only uses stage 2 and 5, and it skips 1, 3, and 4. So because I don't have those available to me, especially stage 1 not available to me, that is detrimental for my SEER rating. So you can see on all of these, the SEER rating drops if I put the 2-stage stat on instead of putting on the communicating thermostat. And that's not just an ICP thing. Other manufacturers with communicating stats have the exact same situation going on. This is a normal thing for these 5-stage communicating type units, but just something to be aware of. All right, so what kind of components do we have in here? I'm not going to go through all the components of an air conditioner. I'm just going to point out things that are different on this 5-stage variable speed unit compared to traditional 1 and 2-stage units. So obviously the fact that we have an inverter in and of itself, that's different. The compressor I already told you is different. It is a DC compressor and it's rotary. The fan motor I told you was different, right? We had a compact ECM without its own control module on there, right? So that's different. Pressure equalization valve is totally unique, and I'll mention what that does. We have an electronic expansion valve instead of like a TXV or a piston on heat pumps on the outdoor unit. And there's also a pressure sensor in there as well, right? So that's what the inverter looks like. It's probably enough to scare most of your techs off, which is why we have service classes for these units, and I'll tell you about those service classes at the end today, because we want these techs to be comfortable with this kind of stuff, and a hands-on class is one of the best ways to do that. But this inverter drives the compressor speed, and it drives the condenser fan speed. It's a pretty compact inverter. It fits in the normal control enclosure housing where my contactor would have been if I had contactors, where my capacitor would have been if I had capacitors. These units don't have those pieces of equipment on there. All of that, if you will, is built into the inverter itself. There is a control board on the bottom right-hand side here that you can replace separately. That is the communication hub, right? So this inverter comes from whoever makes the inverter for them, but that control circuit board is specific to the ICP units, and that is replaceable if you needed to do that. 2-stage with a 2-stage stat, 5-stage with an observer stat. We take the cover off these guys and look on the inside here. The power connection's coming in. Instead of going to a contactor, it's coming right into the inverter. Like we mentioned, it's single-phase 230-volt power. There is a converter section, so you will see some capacitors on there built into the inverter, but you don't have your traditional separate capacitors like you have to start up a normal compressor or a normal fan. We change the convert the AC voltage to DC and change it from single-phase to 3-phase to run it over to the compressor, and then we vary the frequency of that power input to the compressor, just like we do on any other VFD type of application. And then a similar thing happens as we send power out to the condenser fan. So like I mentioned, these are made by Toshiba, and Toshiba's been making rotary compressors for decades. So they make this. It's a fully variable speed compressor. However, our control mechanism is operating it at 5 discrete speeds, and we do that so it's easier to match up the required indoor airflows with these outdoor speeds. We have other products that we've used in different segments of the industry that ramp the indoor fan speed with the outdoor compressor speed, and it's just a lot harder to control. Not bad, not impossible, just harder. So by picking 5 discrete capacities to operate at, it really kind of makes things easier to operate and troubleshoot. So that's why we have the 5-stage version of this. The highest efficiency happens at the lowest stages. So if you can get stage 1 and 2 doing most of the work, that gets you the most majority of runtime, and those are the most efficient scenarios. Anything, whether it's a modulating boiler, modulating gas furnace, variable speed compressor, whatever it is, or even 2-stage equipment, operating it at max capacity is the least efficient point, right? Because I have maximum power input with least amount of surface area relative to power input. So I always want to be at the lowest stages from an efficiency standpoint, as well as a dehumidification standpoint. It monitors itself. It has ramping up start ability. And we still are using 2-stage Copeland scroll compressors on our normal units, although like I said, the 19th unit will probably be phasing down. But that is a normal compressor that we'll be using. It's an industry favorite. And it's still needed in some cases for the low ambient applications like we talked about, at least for now. But it doesn't really have any full modulation. It's just a 2-step situation and only goes down to 70%. For some of you are probably thinking about rotary stuff, and if you're old enough and you were around in like the 70s and 80s, the last time someone tried rotary in America, you probably weren't impressed. But the rest of the world, rotary is that's what it is. That's dominant. So for every 10 million scroll compressors produced in the world, there's 100 million rotary compressors produced. Outside of the United States and Canada, it is by far the dominant compressor type. So I wouldn't be too afraid of it, because if other people can work on it, we can work on it too. Very low failure rates. In fact, the failure rates for this compressor are lower and have been lower than the equivalent scrolls that we've had. So there are some inherent benefits to that. There's a lot of extra things we put on this particular unit, some because it's a rotary compressor, some because it just happens to be the high-end unit to begin with. So you will find on these guys filter dryers, the pressure equalization valve, which I'll talk about in a minute here. There's extra temperature and pressure sensors on here, so we can tell you what's going on with the unit specifically. And then we're running with an inverter. I mentioned the fan motor, which is compact ECM. The fan blades are actually different as well. They're the forward swept type fan blades, or when I showed this picture to my kid when he came in my home office last weekend, he said it looks like a Batman wing. I probably can't say that because I'm sure Batman's trademarked, but it does kind of look like a Batman wing. Although I don't know why there's 3 wings, but that's kind of weird. Anyway, it is an optimized blade for sound purposes to reduce the noise resistance and reduce the frictional resistance and hence the noise associated with that. There's no control module on there. It is built into the the regular inverter itself. We change the fan speed to match the compressor demand, and outdoor air temperature also plays a role. So condenser fan speed and compressor speed are not always in a linear in sync relationship. The outdoor temperature actually tweaks that. So the colder it is outside, the lower we will go with the condenser fan speed, right? Because I don't need to have as much airflow through there to get the temperature drop that I want, because the actual true delta T is aiding me. It's very quiet, freakishly quiet, like I said. You can barely hear this thing running, especially at the lower airflow speeds. All right, the pressure equalization valve, I mentioned that, right? So this concept, his job in life is basically when this unit turns off, right? So it's the end of its cycle, it did its thing, we met at set point, everybody's happy, the compressor shuts off, this pressure equalization valve opens up, and it does exactly what the name of the valve says it does, right? It equalizes the pressure between the low and the high side. That way, when we start up later on again for the next cycle, I'm not really like, deadheading against all this refrigerant that's sitting there. So that's what it does. It increases the reliability because it makes it easier to start later on. And there is going to be a sound associated with that, and we'll talk about that in a little bit here as well. Electronic expansion valve in the unit, over on the left-hand side over there where the red box is, that is the metering device for heat pumps. So you won't find this in the cooling unit. You only find it in the heat pump unit. Because in a heat pump, the outdoor coil becomes the evaporator and the indoor coil is the condenser, so I have to have my metering device outside as well. So we use this electronic expansion valve. I believe it's a 600 step motor, so basically that's variable capacity too. So I got a variable speed indoor blower, variable speed compressor, variable speed condenser fan, and essentially variable capacity EXV. So I got 4 things modulating, and if I hook it up to a modulating gas furnace, then I'll have the gas valve modulating and the inducer fan modulating. So I'll have 6 things modulating that I have to deal with. So you can see why having the correct control on the wall to modulate those 6 things is pretty important. But it allows us to get precision heat transfer. There is a suction pressure temperature sensor and suction temperature sensor on this unit that controls that EXV. So there's some data there that's needed. Like I mentioned, suction pressure transducer, that's where it's at there physically in the unit, so you can see that. The wall control, I already told you, it's got to be on version 5 or later, so we can kind of breeze through that a little bit. And somebody came up with the great idea of saying 5 for 5. If you want 5 stages, you need version 5 software. The algorithm has all the 5 stages built into it. There's additional screens on here that were not on the quote-unquote old observer stat, so the newer ones for the past year have additional screens on there. You will only see those screens if you hook it up to an inverter unit. If you hook it up to a non-inverter unit, you skip those screens because they don't apply to your life. And we'll talk about what some of these screens can do for us in terms of extra data and extra controllability. One of these things we can do is latching, right? So on an AC system, you'll have cooling latching. On a heat pump, you'll have both cooling and heating. So we'll just use the cooling example for right now. So normally it ramps from stage 1 through 5 on its own based on its current indoor temperature situation and set points as well as the outdoor temperature. But sometimes it can be a challenge, especially on a 2-story home when the thermostat is downstairs in the dining room. I may be able to run stage 1 or 2 and satisfy the thermostat downstairs. But when I run stage 1 or 2, I get a lower indoor airflow from my furnace as well, which makes it hard for me to shove air to the upstairs bedrooms. So on really hot days, I may want to skip stage 1 and 2 and force it to go into a higher stage in order to get the higher airflow, in order to get more air to go upstairs than I otherwise would have had happen. So we do this sometimes. I'm not doing this at my house because I have zoning on my system, which eliminates the need to do this little trick. But if I didn't have zoning, I probably would do this. For example, you may lock it at, say, 85 degrees, stage 3 and higher. So if it's 85 degrees or higher, the control will pick between stages 3, 4, and 5. If it's below 85, then it'll use 1, 2, 3, 4, 5, right? So you can do that to force it to get you a little more airflow on those kind of peak type days. And you can pick the outdoor temperature you want to do that at. The summary screen, instead of telling you, 1 or 2 stage unit, it'll say multi-stage on there. So when you first start it up, you'll notice that on the equipment summary screen. The data you can get off the unit, there's additional information that is available to you on the technician screens, not the homeowner screens, but the technician screens. So how many stages are you running? 1, 2, 3, 4, 5. What's the outdoor coil temp, compressor RPM, suction temperature, suction pressure. If you have a heat pump, what's the XV position doing? Right now this was in a cooling mode, so we had the XV wide open in this case. So there's some additional data that you would get on the outdoor unit, in addition to the cool data that you already get on the indoor unit, like blower RPM and inducer RPM and stuff like that, CFM and so forth. All right, some application tips here for you guys as you're deciding when to apply these. One thing I want to mention is that when you go on AHRI to get your AHRI number and certificate, for each combination, and you guys know that a combination is an indoor furnace or fan coil, an evaporator coil, and a condensing unit, right? Those 3 things work together to get you your SEER rating and your capacity rating. You will find 2 combinations for every single one of these. One of them will have the regular evaporator number, and one of them will have the evaporator number plus wall con, right? And you'll get different SEER rating for that. That wall con means you put the correct observer thermostat on the wall. If you didn't do that, then you use the other rating, which will give you a lower SEER rating. This is not something that's just specific to ICP. Train has a similar thing. Theirs will say plus BAY 24 or something like that. Carrier does the same thing. All these manufacturers that have these multi-stage units have a similar type of scenario that they append the thermostat model number to the end of the evaporator model number to let you know which one you have to use. Very much like we used to add TDR on there for time delay relay. It'd be great if they had a separate column for thermostat model number, but they don't do that because AHRI does not recognize that concept. So they basically have to give it 2 different evaporator model numbers to do the ratings. So to get the higher SEER rating and higher HSPF for heat pumps, you need to have the wall con like we mentioned before, which means the observer control. I mentioned the 100-foot line set, so just kind of keep that in mind, and the low ambient. So if you're doing some light commercial stuff, keep those 2 things in mind to decide if this unit's appropriate for your application or not. If it is, it's great for commercial because this thing, in many cases, will fit up through a roof hatch, right, which is fantastic if I can do that from an installation standpoint and not have to get a crane to lift it up there or whatever. But I got to make sure it meets the actual applications for line length and low ambient that match up with what I need. If I have a heat pump, right, I can then run well below the 40-degree number. I can run it down to 10 degrees. Below 10 degrees, I need to have something else handle the heating mode. It'll still run below 10, but it won't start below 10, right? So it'll start down to 10, and if it's already running and the temperature drops below 10 degrees, it'll continue running down to 2 degrees, at which point it would lock out. So I have to have this either in a dual fuel situation with a furnace, or I have to have electric heaters to take care of this load for me, one or the other. If you're further in the south where it doesn't get below 10 degrees, then you don't have to worry about that at all. So I just mentioned that dual fuel or electric furnace when I get below 2 degrees. If you're going to install the heat pump in our normal Midwestern climates, if you're putting it on roofs or in areas that have other high wind, you may need baffling. That may be something you have to do depending on where you install it. And then obviously you need to put all heat pumps, not just this one, but all heat pumps on a stand, so any snow that drifts up on the side of it, right, if you get it up 2 feet above the ground or something like that, you don't have to worry about the snow. I know it's weird to talk about snow when it's 70 degrees out, but so be it. So sound. Like I said, it's the quietest unit we've ever had residentially from any manufacturer that I've ever heard for a residential ducted split system. But there are some sounds that are weird, if you will. So one of them is I have an inverter, and if you've ever heard an inverter run a VFD for a fan or a pump or anything, you know that it has kind of like that higher pitch sound, right? You kind of hear that type of noise, similar to what like your old TV might have done or something like that. So you might hear that higher pitch sound. Older people cannot hear it. Their hearing range is not able to do that. Younger people can hear it. It does not propagate well through buildings, so that's good news. If you're in your house and the windows are shut, you will not hear it at all. Mine is right outside the window to my dining room. Now, granted, we don't use the dining room very much for dining in. It is an excellent Lego building table, and I never hear that unit running at all when the window is shut. And when the window's open, I better not hear it running because that means someone didn't turn the thermostat off, which has happened once or twice at my house. So you might hear that sound. If you get closer to it, you might hear that inverter sound. The other thing you're going to hear is the change of speeds, right? It's going to be ramping up and down. So normally it just turns on, it runs, and then it turns off, right? This is it's going to ramp up and down, so you may notice it being different. It's not a bad thing. That's a good thing, right? Because it's usually a little quieter. And we usually spend most of the time at part load, so it's usually in the quietest operating modes possible. The pressure equalization valve is the thing you have to mention to people. When that cooling cycle ends and that valve opens, you are going to hear a hissing type sound. It sounds like you just took your Sawzall and cut through a refrigerant pipe and gas is leaking out. That is what it sounds like. So if you don't tell people about this, you'll get a call from them a week after you install it saying, yeah, I think this thing's leaking gas. All right, you'll get that call, and then you'll go out there and be like, oh, that's totally normal, Mrs. Jones. And at that point, she doesn't believe you, right? Because you're just saying things after she complained about them. If you tell people in advance, then it really is normal. So when you're installing it, you would mention to them, hey, this thing has different sounds associated with it. I just want you to be aware. These are not bad sounds. They are just different than your old unit used to have. It's going to be much, much quieter than your old unit, but you are going to hear this type of hissing sound after it's done running. That is a valve opening to protect your compressor so that way it lasts longer, right? You don't have to get into the fine details of it technically. Just give them a little heads up so they know what's going on and they don't think it's abnormal, right? They probably won't hear it for a while until they happen to be outside, drinking a beer on the patio. When they hear it, they're going to be like, what the hell? Not that everybody drinks beer on the patio. That's just what I do, but you get the idea. If you have a heat pump mode, it'll have the typical whoosh sound that you have, right? So that's a totally normal type thing. When you're in the defrost mode, you'll hear that. So there's nothing you can really do about that. It is pretty quiet. It's not loud overall, but you can hear it. Now, when you're in heat pump mode, it's wintertime, generally speaking, so your windows are closed, so you won't hear these sounds typically. And your neighbor hopefully has their windows closed this time of year too, so probably no one's going to really notice this. But just be aware that it does happen like all other heat pumps. When we are in defrost mode, we'll ramp it up to stage 2. That'll help defrost it faster, so things happen quicker. When I have a observer wall control in there, I get all 5 stages available to me. So this happens to be a 3-ton unit, so I can operate at 25, 50, 69, 88, and 100% capacity, and there it shows you the sound levels associated with those various capacities. Right? And then if I have a heat pump, then I have slightly different capacities, but kind of the same ballpark. If I was to hook a 2-stage unit to this thing, remember I said we would skip stages 1, 3, and 4, right? So I would only have low and high, which would be stage 2 and 5, which means I'd run at 50% and 100. Right, 50% is still better than a normal 2-stage unit, which would be 70 and 100. This one's 50 and 100, so that's better. And 61 dBA sound is pretty quiet, but it won't be the 56 that you may have, promised them. I don't know if a homeowner knows 56 from 61. It'll still be pretty quiet compared to their old unit, so it might not be a problem, but just kind of keep that in mind. You don't get to the absolute quietest of sounds unless you have the right wall control on there. There is an application flowchart that we can send to you if you're interested. It's also in the book. But I know no one reads books because books are boring. Don't tell my kids I said that. But this is a little flowchart you can walk through to decide if it makes sense to retrofit. If you're putting a whole new furnace, AC, and wall control on, you don't have to use this chart. It's a no-brainer. You're done. But if you want to reuse their existing fan coil, furnace, or evaporator, this walks you through on when you can do that and when you can't. Kind of like just as a check figure in your head, if it's older than 2006, it may be tough to reuse the existing evaporator. You probably will have to change the evaporator even if you're using the same old furnace. So there's a flow chart that kind of walks you through those questions. You know, do I have a furnace or a fan coil? So I go down those paths. You know, what kind of wall control do I have? What's the vintage of my evaporator? And then it tells you what you need to do. So that's available. There's also tons of rating data available in the catalog for these units that you might not see on other similar type of units. So you'll get different ratings for sensible lane capacity for the different modes, as opposed to just telling you what's going to happen in this peak scenario, which is great, and I need that information. What's happening on all the non-peak scenarios, right? Comfort mode versus efficiency mode, stages that are lower than max stage. Instead of just telling me stage 5, it also gives me stage 3 and stage 1, so I can see what I'm going to have going on for capacities down there and airflows. And then it also gives me different indoors. Instead of always giving me the 80-degree indoor temp that we've traditionally always had, it also gives me a row for 75-degree indoor temps, which is probably more similar to what people actually do. Right, so if I look at this, I know you can't read this. This is just to show you that it's there. You can see stage 5 data on the middle, top table, stage 3 in the middle, stage 1 on the bottom table, and then you get both of the indoor conditions for dry bulb temperature. And then for each one of those, you get 4 wet bulbs to go with that. Right, so you can use the traditional 80, 67 if you want to, but if you want to use, 75 and 63, which is probably more common, you can do that as well. And then you have 1, 2, 3, 4, 5 columns for the different outdoor temperatures: 105, 95, 85, 75, 65. Right, and then similar kind of thing going on with the heat pump information. And then I also have a table related to airflows. So tell me the minimum airflows, which is very helpful for zoning systems if you're going to do that. And by the way, these minimums on the zoning are much lower than you've ever been able to go down to before. Right? If I put a 3-ton unit in, which normally would be what, 1,000 to 1,200 CFM. Well, here if I put a 3-ton in, I could throttle this unit down to 236 CFM. So that's a pretty significantly low number compared to what I would do with a normal 1 or 2 stage unit. So if you're going to put zone dampers in, this is probably a really good way to go. I can throttle back pretty far my airflow in order for my airflow to coincide with my BTU needs. But these tables give you that information and tell you the minimum you can throttle down to for these zoning modes, and then also what are the maximum airflows I can do on the various stages. Specifically, the max stage 5 and the max stage 1 are the most interesting. The warranty is 10 years like it is on our other products of a similar type. It's a 10-year no-hassle warranty. You do have to register the unit in order to get that warranty. Otherwise, I believe it reverts back down to, I want to say, a 5-year warranty if you don't register it. So please register this for your customer. Don't think that they're going to do the paperwork, because they probably won't. And then they'll come back to you on year 6 and they'll be like, what do you mean I have to pay for this repair? Well, you didn't warranty it. What are you talking about? All right, so just do it for them. John asks a question right now, asking if you need to use shielded cable. No, John, you do not. You would just use regular 18-gauge thermostat wire. Nothing special there. If you do happen to use shielded cable, then you will need to drain the shield at one end and tape it back on the other so you don't create a giant antenna. But in general, you do not need shielded cable, so just use regular 18 or even 20-gauge thermostat wire. Probably 18-gauge would be a better choice. Anthony types in, what is the cost difference from a regular unit approximately? These 19-SEER 5-stage inverter units are priced to be in between the 17-SEER 2-stage and the 19-SEER 2-stage. So the 5-stage 19-SEER inverter is actually cheaper than the 2-stage 19-SEER unit, right? Which is why the 2-stage is going away completely. So if you were using the 19-SEER 2-stage, you could actually save cost by going to this unit. And if you were previously using the 17-SEER 2-stage, this would be an upgrade. Salus asks replacement parts pricing. I don't have that in front of me. Most components will be similar. Obviously, the big difference would be the inverter. I've had inverters in my own labs, at my training labs, and at my house, and I've not had to buy any to replace them. I would imagine the inverter is fairly pricey. I would just think it would be. But you have a 10-year warranty on it, so hopefully you don't need anything anytime soon. The compressor, in general, should last longer than other compressors. The data on that compressor used, that same compressor used in ductless mini splits, it lasts longer than scroll compressors do in these other units. So I would expect that it to last longer. And generally speaking, fans and compressors that modulate and have inverters on them tend to not have as much startup stress and are not as much heat temperature swing. So those things tend to last longer in general. But I don't know the exact price of the replacement parts. We can hunt those down though if you need them. Power comes into the unit like normal, just a couple installation tips, and then we're going to get a couple, just like four more slides on that. If you have power that's really low or really high, it'll tell you that, and it will be a problem. It used to be a pretty tight threshold on these things, but now the threshold has been relaxed. But still, if you have less than 197 volts on something that's supposed to have 230, you got bigger problems anyway. And that really low or really high power causes problems with the compressor longevity. Your old normal unit that was at that house would have just kept running, just really been beating itself a little bit unnecessarily. This unit, if you have freakishly low or freakishly high power, it'll actually shut off to protect it until you fix the power problem. Control wiring, like I said, it's just 2 wires for the outdoor unit if you have the communicating stat. If you don't, then you have to run all the normal wires out there, and they're showing a heat pump here, which is why you got 6 wires going out there. Charging the unit. Charging is a big deal with these units. Not because it's an inverter and not because it's a rotary, but because it has very small condenser coil volume, right? So if I was to take a regular 2-stage, in this case 2-ton unit, and I overcharged it by a pound, that would be 7% overcharged. If I overcharged one of these smaller units by a pound, it would be 19% overcharged. So that's a pretty dramatic difference in how much I've accidentally overcharged it. So the charging procedure becomes fairly important in this regard. Because of the smaller volume of refrigerant that the system holds. Right? I'm just trying to think like off my head, like a 2-ton unit may only need, for like a 20-foot line set, probably needs less than 6 pounds of refrigerant. It's pretty small. Pete asks how well the inverters are protected from voltage spikes and surges. They are protected well. That is why they have these limits coming in on them. You also will probably notice if I got a picture, I don't know how far I got to go back to get a picture, but see if we can find a picture. There's one on there, but I'll find another picture of one of the inverters here for you. There's a lot of what do you call it? Ferrite cores and devices like that on here. Here's one, right? So 1, 2 ferrite cores on this one. Some of the bigger ones may even have more. There's a core built into this assembly over here, right? And there's a core there. There's a core there. Those ferrite cores are very similar to, if you look at your laptop you're probably sitting in front of right now, on the power plug, there's going to be a round cylinder-shaped bulge in the power cord. That is one of these ferrite core type things in there, and that's to protect for interference type things as well. But yes, there is pretty good protection on these things because they are fairly pricey components, so you don't want them to just get a power spike and fail. That kind of thing. So charging is important. There's a whole charging procedure. We go through this with the techs in the class. You can also adjust it by weight, or you can do it by subcooling like you normally would. So that kind of stuff is in there, but you definitely have to pay attention to the charging these units. Is a big deal. I mentioned the control board on the bottom is replaceable if you needed to replace it for some reason, as opposed to replacing the whole inverter. If you want to learn more about the service side of these units, we do have 2 training classes coming up. I know my slide says hands-on. The one in Aurora has a hands-on component to it. The one in Melrose won't actually be hands-on because we don't have an inverter installed in that lab yet. We thought we'd get a chance to get it installed this month. We did not. So still have the class going on. It just won't have a live fire unit in there. But it still may be beneficial to you because it may be closer to you than going to the Aurora lab. But those 2 classes are coming up May 16th in Melrose in the evening and May 23rd in North Aurora in the morning. We have the training classes for the technicians on how to install and service these units and properly charge them. Additionally, there's how you can register for the training. If you go to the website ExcelsiorHVAC.com and then click on training or /training, either way will get you there. You can register for these classes. They are free, but you do need to register for them in advance because they are fairly small classes on purpose. So there's more interaction with the instructor and the students. I think it's like 12 or 15 students max. So if you're interested, you should definitely sign up quickly for that. Additionally, you're going to start seeing in May and then into June on our YouTube channel. There's 4 videos that we're going to post on there for different topics related to the service side of these units. Right, so how does the unit operate? How does the pressure equalization valve and expansion valve work? How do you charge the unit? And then how do you access some of these components in there? So that video series is coming out, and like all of our other YouTube videos, they're like 8-10 minute type videos, right? You can find those on our YouTube channel, which is right there for the link, or if you just go to YouTube and type in TEC Tube, it'll be the first one that comes up on your search there. And there's a bunch of other videos already on there, but starting next month, we'll have these 4 videos being released, probably 1 a week for 4 weeks kind of thing. I don't see any other new questions typed in, so I'll leave it up for like a minute. If you have another question, do please type it in. Otherwise, I'll let you know that this was recorded. There's my email. Sorry, I don't know why it came off the screen. This was recorded, so if you have a coworker that wants to watch it, in about 2 hours or so, it'll be uploaded, and you can watch the recording that way. And you should automatically get an email telling you thanks for attending, and here's the recording link if you want it. All right, I don't see any further questions, so I'm going to go ahead and end the recording and end the webinar. Thank you guys for your time. I appreciate it.